In this chemistry, we have learned the different concepts of basic chemistry in our previous classes, such as in our 8th class we will start with how to write a chemical equation and what are the different formulae and everything, right? And in 9th class and 10th class we will be discussing how to balance it, right? Its qualitative and quantitative analysis, right? With the continuation of that, in our higher classes such as 10th class, we learned that the different models of an atom. What is an atom, right? What is inside of an atom? What is a particle? What are subatomic particles and everything, isn't it? In this first year, we will discuss about all the basic concepts of chemistry, such as in the starting chapters, we will discuss about the atomic properties, that is, what is an atom, what is its position in a periodic table, how does it combine with another atom to form a bond, what kinds of bonds, right? These are the basic things which we actually study in the initial chapters. After that, we will discuss about the state of it, how the atom is going to behave in an external environment, what happens in a constant volume or in a constant pressure, or like that. Is it clear? Similarly, further we will discuss with its qualitative and quantitative analysis. Especially we discuss about quantitative analysis. What happens if this constant is this, if this constant is, it depends or it varies based on the volume and their masses, right? And the further things we will discuss about different material properties, such as we will study about 1A properties, I mean the elements in 1A, we will discuss about the elements in 2A, then we will discuss few more topics about water kind of things, and finally we will end up with organic chemistry, right? Organic chemistry is a basic organic chemistry, basically it includes the whole family of hydrocarbons. How does it behave when it reacts with the different functional groups, right? What are its applications? We will discuss about all such things in our further classes, right? And we will have few external things such as environmental chemistry, right? General chemistry, such kind of things, okay? And when it comes to the second year, we will have most of the same things which are continuation of our first things, right? Therefore, I can clearly tell that the first 3 chapters are the basic to understand almost every kind of reaction of a chemistry, right? Shall we start with our first chapter? Right. Let's start our first year chemistry, where the first chapter includes atomic structure, right? You would have studied about what is the structure of atom and what is inside our atom in our previous classes, isn't it? What did we learn in that chapter in our previous classes? We have learned that the whole atomic structure is being initiated by a person. What was his name? He was Dalton, right? Dalton initiated the basic atomic model, how the atom has to be. What is actually the basic definition of an atom, right? He defined an atom in terms of law of conservation of mass, law of conservation of proportions, and so of things, right? And he also defined that an atom is an indivisible particle, right? After that, we learned that there are few people such as Thomson, Rutherford, Bohr atomic model, Bohr-Sommerfeld model, isn't it? And we also discussed about few scientists who did experiments to find the actual atomic structure, such as Planck, right, Aufbau and Hund's rule, right? These are the different things we discussed in our previous classes, isn't it? Let us start our session with a basic subatomic particles, right? How are they discovered, by what experiments, what are the different activities they did, right? What are the conclusions? How could they conclude that these particles are nothing but are electrons, protons and neutrons, right? What are the basic properties of them, right? These are starting from this we will start our chapter. After that we will go to different models and we will end up with the different activities such as electromagnetic radiation and when photoelectric effects, Hund's rule, Aufbau's principle, Pauli's exclusion principle, right? Then what are the prerequisites of this chapter? The prerequisites of this chapter is, the only thing is we will be starting with the basic subatomic particles. It's okay till the end of our modeling, right? That is, it's okay till the end of defining the models and studying about their postulates and drawbacks. After that, we will start with electronic configuration. Therefore, we expect you to be perfect with electronic configuration of most of the elements, at least 30 elements for this first chapter. Is it right? Let's discuss. See here, what is an atom? From where did this atom come? Right? The atom's history is somewhere in the Greek and Indian philosophers also, somewhere in 400 BC kind of time. Right? They always define it as a basic fundamental block. Right? A basic fundamental block in the sense, for example, if I take some particle or if I take some chalk piece, if I break into pieces, yes, it will be divided into pieces. If I divide it again furthermore, if I grind it, right, we will get a finest particle, right. The finest particle, again if we divide into more finer, we can't divide it, right. The last most particle which we can see with our naked eye, which is only microscopic, such a thing is can be defined it as atom, right. Is it clear? Finally we can conclude it that it is a fundamental building block, right, of a matter, because a single a basic block, it combines together to form a building block, right, which becomes a large functional block, isn't it? Is it clear? Similarly, what was the theory behind this atom, right? Who proposed this? From where did it start? Is Dalton was the first person. What is the actual theory of an atom? From where this atomic theory start, right? In the basic atomic theory, the whole atomic theory was started by a scientist named as Dalton. You would have heard about him. Dalton is the first person to describe about what is an atom. He did not tell completely, but it was a very drastical change of in understanding an atom, right? What did he define? What is an atom? Let us discuss more about Dalton in his postulates. Before going into that, we will start with a few experimental observations made by different scientists, right, to understand the basic subatomic particles, right. Shall we start? Let's see. Now see here, what was the situation before starting the experiments about this subatomic particles, right. The situation was like that, they could not account for a particular atom. No one knows that it is an atom or something else. They could not define it, right. It was a completely smallest particle, right. We don't know how to compare different properties. Now we could know that we could not even differentiate two different materials, such as if I take some HCl, if I take some sulfuric acid H2SO4, we don't know whether those both have same properties or not. At least we know that it is an acid right now, but we don't even know that what kind of properties does it have, what kind of molecules does it have, how does it varies in external environment, how to estimate that, isn't it? Then how did they start the experiment? What happens when an light incident on that? How does it behave in an electromagnetic condition? We doesn't know anything. That's why they started an experiment, different experiments. From that they discovered few things, such as they are called as subatomic particles. See here, they don't even know that these are subatomic particles. They discovered different kind of matter in that fundamental block, right. They named them as finally subatomic particles. What are those? What are different subatomic particles we know till now? That is an electron, a proton and a neutron, right. Hope most of the people, at least they would have heard about these words, isn't it? What is an electron, what is a proton, what is a neutron, right. Now let us discuss about the actual history behind the discovery of these subatomic particles, right. Let us begin. Let us start with the discovery of electron. Why was it discovered? How was it discovered? See here, whenever you study about few kind of historical inventions, better learn why it was discovered, right. Is it clear? They will because we are telling that there is some electron, there is some proton, there is a neutron, because we know that someone discovered it, someone named it, but in those days no one knows that there is something called as electron, there is something called as proton, isn't it? What is the reason? They will be doing some other experiment, they will get some other result, isn't it? That is actually called as an experiment, right? Because they will try to find out some other thing, they will get some other thing in front of them. Then they will start discussing about them, they will start doing more experiments on that particular result. Then only we are able to get the different kinds of things, right? Now let us start with discovery of electron. Discovery of electron, how the electron was discovered, right? Let's see now. See here, on the basis of different experiments, many scientists were trying to find out what are the different the basic fundamental blocks in a matter. Among them, Faraday was one of the leading scientists, in which he performed various experiments, right? Because Dalton had given few things that he did many examples such as on different materials, right? Based on that, he gave the law of conservation of mass and kind of things, and he also told that there are few more particles in a basic atom, right? What could be those atoms? Then Faraday was one of the person who started different experiments on these subatomic particles. Among them, one of the experimental was this discharge tube experiment. What actually a discharge tube? A discharge tube can be simply called as, it is a glass kind of things from which it is completely evacuated through a vacuum pump. What is a vacuum pump? It pulls off all the air inside it, that is, it pulls off everything, whatever the particles inside it, right, and it seals it off, right, because there are very less particles or almost all zero particle count, right. Actually this can be calculated by using a particle counter, that is another instrument. Based on that, it is, this discharge tube is completely evacuated, right, it is evacuated by using a vacuum pump. Since there are no particles, the whole vacuum pump or the whole this discharge tube is maintained at low pressure. It is almost all some 10 power minus 6 to 10 power minus 9 Pascal in the orders of, right. That is a range of a discharge tube, right, that is a range of a pressure in the discharge tube. Then here he maintained a setup that he placed two electrodes, he placed two metal electrodes and he connected to a battery of a very high voltage. Then he starts a battery. Before that, what is the basic thing we have to understand is, remember, like charges repel and unlike charges attract, right, which means we know that the current always passes from one to another electrode. Then which electrode to which electrode, what is that is going to pass? This is one of the basic thing. From that, before going to understand this, let us discuss about one more experiment of Faraday, that he always used to do experiment, that he used to take a liquid, he used to place two electrodes in it, he used to switch on the current. What happens? When the current passes from one electrode to another electrode, he observed that some matter used to deposit on the electrode systems. What is that matter? To understand that, he placed everything in a vacuum pump, okay, he placed everything in a discharge tube, okay. See here, remember, the negative electrode, it is connected to first metal electrode, therefore it can be named it as cathode, right. What is a cathode? A cathode is a negative electrode and one more positive electrode is connected to the opposite side metal electrode. Is it clear? Then what happens if we switch on it, right? Let us go by voltage. At 0 voltage we can't observe anything. As long as the voltage is increasing, when the voltage is increasing, he observed that there is a electrical discharge, right. He observed that there is some current flowing through the circuit. What is that current? Then he could conclude or he could decide that, and the electrical discharge through this gas could be observed only at low pressure and high voltages, right. He observed that the discharge tube, whatever it is, the discharge tube with a very little kind of particles through which the whole current passes only when it is maintained at low pressure and the high voltages. However, we are maintaining it at low pressure using this vacuum pump. Then what about the high voltage? We are applying it from the external. Is it clear? Is it right? What is the condition for electrical discharge through a vacuum tube? The condition is that the discharge tube has to be maintained at very low pressure and at high voltages, right. Then there are few particles which are being moving from this side to this side. What kind of particles they might be, right. See here, the cathode is releasing those particles, then we can tell those particles which are released from cathode to anode, they can be called as cathode particles or cathode ray particles. Is it clear, right. This ray is called as cathode ray. Cathode ray is the set of charges or the stream of particles released by a cathode. Is it clear? See here, what is written is for a sufficient applied voltage, which means it requires a minimum amount of voltage to start generating the charges. That is, for a sufficient applied voltage, current starts flowing through a stream of particles from cathode to anode. What are those particles called as? Those particles are called as cathode rays. These particles are called as cathode rays, right. The stream of particles are called as cathode rays. Is it clear? And those particles can be called as cathode ray particles. Do not just conclude what is the name of that, right. We know that, but this is the process he did. What is a cathode ray? How does it start, right. This is how he did the experiment. Then he concluded few of the things. What are those? The main conclusions of this experiment were, he could tell that the cathode rays always start from cathode to anode, right. And one more thing he did was, see here, he made a small hole in this, a very small hole, right, and he covered this outside portion with a zinc sulphide, right, which can be simply called as fluorescent or kind of names. See here, then these rays, they pass through this hole and they get incident on that zinc sulphide. What happens? There he could observe a black spot. Why it could be? What did he conclude? Let us see, right. What was his experiment? Once again, see here, he took a discharge tube in which the whole it is evacuated, the whole gas is removed, right. Most of the thing, it is almost zero pressure, right. Then he placed two metal electrodes inside it, then he connected it to the high voltage, right. Then as soon as he is increasing more and more and more voltage and maintaining it as very low pressure, he could observe that there is some current flowing through the circuit. From where did this current come is, he observed that there is some stream of particles flowing through cathode to anode, right. Since it is a glass transparent, we can see there is some ray passing from cathode to anode, right. Then he named them as cathode rays, and he named this stream of particles or that ray is cathode ray. And after that he did one more thing is, he made a small gap in this and he covered the back of that this glass or the back of this with a zinc sulphide. He covered with a zinc sulphide, he coated with zinc sulphide. After flowing through this anode, when these get incident on that zinc sulphide, he could observe that there is some black spot. Then what are its observations? Let us see now. See here, he tells that always the rays passes from cathode to anode, right. Remember that, always the rays passes from cathode to anode, that is from a negative charge to the positive charged electrode. Remember that, those are the basic things. And one more thing is, whenever, that is the first postulate, right. What is the first postulate? The charged particle always moves from negative electrode to positive electrode, which can be simply called as a cathode to anode, right. Similarly, he also tells that when did he conclude? Whenever he sees there is a ray passing from negative to positive electrode, then only concluded that there is something, a stream of particles are passing, right. Then he concluded that this ray of particles, it does not change until and unless there is some external environment, which means it depends on the way which is trying to project it. See here, there is a zinc fluoride which we are using, that is some fluorescent or phosphorant such as zinc fluoride kind of thing. With that only we could observe there is some black spot, right, which means we can clearly conclude that when the ray passes through that or when the ray incident on that, then only there is some glow on that, right. Then one more conclusion is that See here, there is no magnetic field, there is only electrical field, right. We can observe those ray of particles only in the presence of either an electrical field or in the magnetic field, right. What happens if these particles are placed in an electric field or magnetic field, right. When these are placed in electric field or a magnetic field, they behave in a same principle, that is, they behave in the same, they passes from negative to positive, right. See here, since these are released from negative electrode and these are getting attracted towards positive, then these can be called as negatively charged particles, isn't it? Negatively charged particles, that is why they are getting attracted towards the positive electrode, right, and they named this as electron, right. And the final conclusion was, whatever the characteristics of a cathode rays or electrons, that does not depend upon the material, they always depend upon the nature of the discharge tube present in it, right. Is it clear? That does not depend upon which atom it is, which material it is, they just depend upon the way it passes through. Is it clear? This is how an electron is discovered. Finally, that is why we can tell that whatever atom it is, it has an electron, right. Therefore, an electron is one of the basic constituent of an atom, right. Let us discuss a few more things about electron, right. Let us see that. The next thing we will discuss is charge to mass ratio. Why do we need this charge to mass ratio of an electron? See here, we need to know the basic qualities of a subatomic particles, that is, we have to know the basic mass, charge, right, how does it behave in different environments. See here, actually this was discussed by a person named as J.J. Thomson. J.J. Thomson is the first person to give the ratio between charge and the mass ratio of an electron, right. How did he conclude this is, whenever see here, we have discussed that the electron will behave differently in different conditions, right, but the behavior which is same in both electrical and magnetic field, right. Let us assume there is a setup in which when the both electrical field and magnetic field are applied simultaneously. For example, just now we have seen that discharge tube, right, the electricity or it is being placed to a metal electrodes. What happens if a magnetic field is placed in perpendicular to that? What happens to it? See here, there are different constraints. For example, one thing we can understand that since there is completely negative charge, that is, the whole electrons are there, right. Since the electric charge completely includes the whole electrons, then we can directly tell that when the magnitude of the negative charge on the particle, as long as it is increasing, obviously the deflection between the electric and magnetic field will also increase, right. Is it clear? That was the first conclusion by this J.J. Thomson. And one more thing, he tells that the mass of a particle, if the mass of a particle is very high, what happens? If the mass of a particle, usually we know that whatever particle it is, if the mass increases, it cannot travel to more path, right. Here the mass plays a very key role, right. Here he concludes that as mass is increasing, the deflection of the electric and magnetic field also increases. And one more thing, he tells that what if electric field is increased a lot and magnetic field remains same? What happens if magnetic field is increased a lot, right? What happens to the electrons, or what happens to the path of electrons? He tells that the path of electron completely depends on the strength of electrical and magnetic field, right. Is it clear? We know that as electric field increases, it changes one path, as magnetic field increases, it changes another path. Therefore, he concludes that whatever you apply, the electric field and magnetic field are to be balanced, so that the electron moves in a fixed path. Is it clear? From that experiment, he concluded that the ratio of charge and mass of an electron is given by 1.758820 into 10 power 11 coulomb per kg, right. This is the ratio he gave that. And one more scientist named as Millikan, he did oil drop experiment. You can find that in your textbooks. From oil drop experiment, he concluded that the charge of an electron is minus 1.6 into 10 power minus 19 coulomb, which we are using even till now, right. Since it is a negatively charged particle, there is a negative sign placed in front of a number, right. If we substitute this value in this, we get the value of mass of electron, that is 9.1094 into 10 power minus 31 kg, which we use in popularly as 9.1 into 10 power minus 31 kg. Is it clear? Now let us discuss the discovery of electrons and let us discuss the discovery of protons and neutrons. Let us see them. Till now we have seen the discovery of electron and its few properties. Now let us discuss about the discovery of protons and neutrons. See here, unlike electrons, the protons are completely a positively charged kind of things. We have seen the modified discharge tube, that is, we have made a hole in the one negative electrode and we have placed that fluorescent kind of thing, right. In that discharge tube, after doing many and many more experiments from that, they could find there are few positive charge rays, those are called as canal rays, right. And these positively charged particles, they defined it as protons, right. And these protons, always these positively charged particles, they are not like electrons, right. They depend on the nature of gas through which it passes through, right. Before we clearly discussed that there is no dependence of any nature or any material, right, but the protons depends upon the nature through which it passes through, right. And the charge to mass ratio, it always depends upon the gas from which it is originated, right. There in the electrons, it does not depend on anything, right. And there is one more thing, that is a neutron, right. Is it clear? What is an electron? A negatively charged particle is called as an electrode and a smallest positive charge, right, or else we can define it as a smallest and lightest positive ion can be called as proton, right. This definition, it is better to remember because we will discuss which is that positive ion which is very small in size and which have very light weight, right. We will discuss about that atom in our future classes, that is called as simply a proton, right. And one more point is a electrically neutral particle which is having a mass slightly more than a proton, these are called as neutrons, right. What all we discussed in this class? We discussed about what is a electron, what is a proton, what is a neutron, how are they discussed and what are its basic properties, right. In the next class, let us discuss with the few atomic models in our next class. Is it clear for today?